Okay. Good afternoon, all my dear students. Actually, now this session is DS data structure, right? But because of so it's busy with some other work, so I have to continue with the MP lecture, microprocessor, and whatever my lecture is there on coming Tuesday, DSY at same time. So that lecture handled by that DS lecture. Okay. So just for your kind information, uh, okay, again only 10, 8 students are here. So again 7 students. Okay, again 1 or 2 minutes we will wait for remaining 7 students. If you have contact number of them, please you call and inform them to attend the lecture. Okay. Again, I'll take 2 minutes. Within 2 minutes, all of you join here. Okay, dear all students, actually, okay, am I audible, right? My screen is visible to everyone?
Yes, sir.
Yes, sir. So actually, I wanted to start your lab session on Tuesday. Okay, because of we are swapping the lecture, so Tuesday I may not get to the lecture. So today only I will start the lab session instead of Tuesday. Okay. So in yesterday I sent you that TOSM software. So how many of you installed? I think everyone is installed. Maybe 1 or 2 students they are may facing the problem of computer or laptop because of they don't have any machines. Okay, you have another solution, but uh, I'll give you a solution on Monday or Tuesday. Okay, so that Android software I will tell you. You also tried in the Google just for clicking my that Android application of TOSM software for the mobile. With the mobile version, you have to mention you will get it. That otherwise, only 1 or 2 students don't have that machine. So I only installed in the machine. I'll tell you one separate class. Okay. So here, uh, before going to yesterday, I given one small program demo. That one more dummy demo just for the execution. How we are going to do the execution in the TASM. Okay. So here, uh, I will give you one file for you. That is how we are follow the commands in the TASM software. How to create one good file here? Just how to open it. Just wait here. I'll give you one better file for that. Add subscript docs. MP program one. Okay. So it is may not be there here. Directives. Yeah. Download some guidelines. Okay, just a minute. Yes. It is not downloading here. The only thing I have to prepare some software guidelines. Just a second. So okay, anyhow, I will send you later. So first we will continue with the classes. After that, I will send you that TOSM software. Okay. No, already I sent the TOSM software to you just for the guidelines. Yes. Okay, I'll send you after this class. Okay. So now what we will do? We will go through the programs. So that first program on the TOSM software. So dear all students, anyone facing problem with installing the TOSM, whatever I sent yesterday?
No, sir.
All of you installed, right? Okay. So here, yesterday I given 4 commands. What are those 4 commands? Those 4 commands are nothing but that. That is, first one is edit file command. Second one is TOSM file command with the compilation. And the third command is that is TOSM link with the objective file, that is t-link, name of the file with the .obj. And the last command, that is TOSM debugger. TD means TOSM debugger with file name .exe, means executable file. So 4 commands we need to play with them, means to run the microprocessor program in TOSM software. These 4 commands are fixed. So please don't forget these 4 commands for the microprocessor execution of the program. Okay. So here, same here, what we will do, we have to open again. Please, all of you open the TOSM software. So in my machine, I have to use TOSM software. This is the icon. Double click on this icon. So we have to getting TOSM software is opening with a DOS prompt. that is DOS water status. Okay, so this is the window, that is command prompt window of TASM software. So in this command window, we have to give first command. So today's class is very important. Please, all of you listen here. Don't look into here and there. Please, 100% you have to concentrate today's class. Okay, because the entire basic things of how to execute the program in the microprocessor, I have to explain you. So this is the first. After clicking TASM software icon, you have to getting this window. So in this window, what you will do? First, you have to give the first command, whatever 4 commands I given in yesterday. First command you have to give here. The first command is what? That is editable file. EDIT, edit to the file. Which file? The name of the file you have to give by your own. Any name you have to give. Any name you have to give, that is becomes a, that is saved with name of the file in the editable file. So for example, for the today's first program of microprocessor, I will tell you addition of 2 numbers. I will tell you, we'll start. Even C programming also you have to start with at the beginning, right? You have to print your name. After that, you have to do one addition operation. Int A equal to int B equal to something. Enter the A value, enter the B value, and you have to do the addition. That is sum variable. Sum is equal to A plus B, and you have to print the sum value. That is the result. So small program, right? At the beginning step. So here also we have to start with very small program, that is addition. So for that addition, I have to take the name of the program is add, ADD. My program file name is ADD, add. In the short form, I have to do. It means that addition of the program, that is name of the file. Any name you have to give, single letter or multiple letter, or simply XYZ also you have to give, or your name also you have to give, not a matter. Any name, alphabetic name you have to give for the file name. So here my convenient, I have to give add, means addition of 2 program representation purpose. I have to use the add word, that is for the file name. After that, dot, what is there? ASM. This is the first command, that is edit space, give the space, one gap. After that, give the file name. Name of the file here is add with .asm extension. With .asm extension. So the ASM extension means that is TASM file. TASM file. Okay. So after giving this command, just press the enter. You will open the editing file. So here all of you observe, I have to just enter the button, this editing window, that is program file window for typing the program, microprocessor program, that window is opening here. All of you open this window by using first command. See, if anything I have to ask you, how to just message yes sir, just yes. Okay, yeah, at least I come to know you are continuing with the not with B. Okay, so this is the editable window. In this window, in this window, we have to start to type the program. There is a one program. I have to open it here. Otherwise, the one program code I will give you, source code of one addition of 2 numbers. Just for addition of 2 numbers, I will give you one program here. This is the program. Okay. This is the one program source code I'll give you. So come to the microprocessor group. In that group, I have to dump first program code, that is program for addition of two numbers, or we have to say two 16-bit number. So this one I will forward to you. Okay, I think you got this program code, right? So there is a one program code I dumped in the WhatsApp group. So use this program code, and you also type along with me. So here I have to type it here. So see, first I will type one program, entire one program I have to type on the Windows editable window. After that I will explain you. Otherwise, see, this is the program. So all of you studied architecture of 8086. Okay, so just I will refresh you again in the architecture of 8086. What are the components you have studied? Can you remember? Please tell me one by one. Very simple. Please, anyone, what are the components of architecture 8086, not 85? Revise, turn over your previous pages. In the second unit, I have to cover first topic is architecture of 8086, right? Please tell me what are the things you studied in that. So there are the two parts you studied, right? That is bus interface unit and execution unit. So I will open it here, that file. You may have forgotten. Every day I need your study day by day. If you are forgetting, then you can't understand anything again. Okay. So here that bus interface unit and executable unit you studied already, but no one is ready to say that components in that you have to study general purpose register, special purpose register, yes or no? But no one is not remember that. That code segment, data segment, extra segment you studied, no? See, I'll open it here. This is the architecture of your 8086. Okay, so in this, what are the things you studied? Make it as enlarged. So here you studied a special purpose register, that is SP, BP, SI, DI. What is that? Destination index, source index, base pointer, stack pointer you studied, right? And these all are general purpose register. We have to use it A, B, C, D, right? Four register we have to use it, and with the higher bit and lower bit. Put L or H. That is higher is 8 bit, lower is again 8 bit. We studied, and here in the bus interface unit we studied extra segment ES, code segment CS, stack segment SS, and data segment DS with the instruction pointer. Please don't forget. This is already covered architecture of 8086. Okay. So dear students, what is this ES, CS, SS, DS and instruction pointer? These are nothing but memory segmentation. This is entire the memory. In the entire memory, you have to separate, you have to make a subdivided into again these 4 to 5 sub division of the memories. Okay, that is extra segmentation, code segmentation, stack segmentation, data segmentation, isn't it? So this with all this uh, control system and logical operations with arithmetic operations, arithmetic and logical operations, you have to do the performance. Okay, so here today's for the first program, for the sample or basic program, I have to show you arithmetic operations. That is architecture of 8086. Arithmetic operation with these memory segmentation, with this memory segmentation. So in this memory segmentation, first I have to use CS, code segment and data segment. At first, code segment I am using, data segment I am using, and this arithmetic operation I have to use it at the first program. So for that, please you have to remember whatever I covered. So in the first unit, I have to cover 8085 microprocessor. In the second unit, I covered 8086 microprocessor. And in the third unit, I covered what are the different category of instructions are used in the microprocessor. That's what. Still up to today, I didn't touch the lab program. So once you perfect with these things, first unit, second unit, and third unit, if you are perfect in that, this lab programs or lab session is nothing for you. That much easy you will get it. Otherwise, it may harm to you. So what you will do every day, you have to do the study. Whatever we have to cover on that day only you have to complete your work. Okay, so this is the thing. So in the architecture, today I am going to do the first operation, that is arithmetic addition operation with code segment and data segment. Please assume this one. Okay, so now come to this point, that is here. Where is that? Okay, so here what I have to do, I have to use some, see, this is the first line of the program. Why I am telling you, repeat again and again. This is CS. CS is for what? Code segment, and DSP is for what? Data segment. Whatever you used in the microprocessor architecture 8086. So here I have to use assume. All of you take this code and start to type along with me if it is possible. Otherwise, you have to listen my words and my demo. For the first program, better you have to listen. Okay, later on you will practice it. So DS means data. So just assumption, because we have to tell that our compiler, just you have to assume the CS is in the sense code segment. Shortly we have to write it as a code, and the DS in the sense it is a data segment. That is shortly we have to write data. That is assumptions of compiler to the microprocessor at this first line is says. Okay, so next line, once we have to assume that code segment and data segment with CS and DS. Next, what we will do? We will do for data segment. Okay, in the C program also you have to declare the variable. Up to that you are using that variable, right? To assigning any variable, any value to the variable. Like that, you have to assume CS is the code segment and DS is the data segment. So that data segment and code segment later on you have to use in the program code. So here I have to take the data, one variable, that is A, with the data word. So DW, yesterday only you have to study data. B means byte, W means word, and DW means double word. I have to take it as a double word, that is 119H. 11911 hexadecimal value I have to take. After that, I'll take a B variable. So with the B variable, again double data word. With the second number is 2272. So this is the hexadecimal value. So 1191H means 1191 hexadecimal value, and 2272 another hexadecimal value. We are going to add these two values. Just a very simple program. Just we are going to add. So this is the data. These two are the input data. Whatever input data we have to take, one as a variable A. In that variable, we have to assign the first value, first data, that is 1191. And in the variable 2, there we have to assign the data, that is 2272. Okay. So here what it will happen, that data segment is only, we have to take two data because our aim is to addition of two numbers. So here. So that two number is enough for this program. Very simple program. That's what I have to take. After that, data ends here. Here, data is ends. Okay, data is ends. So only two variable. So this is the area of data segment memory in the architecture of 8086. Okay, so after that we will go to next segment. So this is the DS data segments. We have to use this much memory, and next we have to go for CS code segment. So code segment, in that code segment, real code means what? It is a program code. So in that program code, you have to start your logical source code. So here, that is, so in the C program, you are using main, right? Int main or void main. But here, you have to take start. You have to take start in the microprocessor with the colon. So int main, you are taking opening and closing braces, right? But here you have to take colon. After that, you will use the source code. So that source code is what? Move AX comma data. After that, you have to use second instruction, move DS. Take first, all of you type this program. I will explain at the end. Okay. First, you have to observe that typing DS AX, how these instructions and how these instructions comes. I'll tell you. Next one is move AX comma 4C00H. There is a one value. Up to that, move AX comma A variable. That is A variable. What you have to do. Next is move BX comma B variable. After that, what you will do? Once you have to dump the value of A variable data, first data, and the second data as B variable data. After that, you have to go for addition. That is AX comma BX. Okay, addition of AX comma BX. After that, what you will do? Again, this result, move sum comma AX. Move sum comma AX. So here you have to using the sum variable, but here we are not declared it here. So that's what sum variable also you have to declare. So sum is nothing but what? It is also a double word, double data word, but how much we don't know. That's what we have to give the question mark here in the data segment. That's what we have to use the sum variable here. So after that, int 3. This is the interrupt. So interrupt still we didn't taught is all the interrupt chapters we have to taught in unit number 5. So after that you have to wait just for use the interrupt 3. After that, what you will do? This is the program. Enough. That is again how data segment. That data segment you are ends. Same way you have to end the code segment here. Code segment. Code segment you have to end here. No, that is code ends. Code ends. After that, one more start. Main also ends. After that, you will end main and start. That is end start. So this is the program. This is the program. Please all of you listen. I will explain you now. So please, am I audible? Screen is visible to everyone?
Yes, sir.
Yes, sir.
Yes,
Okay.
sir.
Okay. Please all of you more concentrate on this first program. Okay. Once you perfect with first program, later on programs are very easy to you all the peoples. I'll give you that much surety. Okay. So bit by bit, line by line, every line, every word, even every letter, we have to understand this program. Okay. Once we understand this program, later on, we have to get too much easy for remaining. So please, all of you come for the explanation. Please more concentrate on this. So this is the one simple program just for addition of two numbers. Addition of any two numbers in the 16-bit hexadecimal, okay, or any number. Generally you have to take it as, okay. So in that we have to take two sub memory of the microprocessor architecture 8086. So for that, the addition of two numbers, what are the basic things we need for the addition of two numbers we have to need. There is a first number and second number. So first number we have to take it as 1191. Any number you have to take, your choice. And the second number we need, second number we have to take 2272. And so these are the two values. These two values we have to store with some variable. That variable for the first value, I have to take it as a. I have to take it as a variable. And for the second value, I have to take it as a b variable. So and this, so how you have to use, that is like an integer, that is like a long, short int, long int, double. Yes, you have to use it, in the C programming. Same way we have to use it here, byte, word, and data word. So byte is very small, that is only for 8 bits, and word is for 16 bit, and this data word is for 32 bit. Again, double of word. Okay, it is data word, or you have to say double of word. So for that, full length I have to take, even D also you take, W also you take, it is your choice. Okay, this is like a data type. So in my case, I have to take A as a variable, DW, that is I have to take as a data type, data word or double word. So for A and B, two variable, the 119 which I have to store in the A variable, and 2272 which I have to store in the B variable. And these are what? Input data for our program. So you have to enter values from the keyboard. No, enter the value of A, printf. After that, percentage %d ampersand A from the scanf in the C programming. Like this, we have to enter this value through the data segment, the memory of data segment in the architecture of 8086. So 4 different segments are there: data segment, code segment, extra segment, and one more is stack segment. But in this basic program, we have to use the 2 segments: code segment and data segment. So in the data segments, we have to declare the inputs. We have to declare the inputs, and those inputs value we will assign to a particular variable. That is the meaning. Okay. So all of you understood this data segment, and this data segment and this code segment we have to know, being a human being. But how the compiler will know? For that compiler, the user, nothing but us, we have to tell to the compiler, a compiler, you have to assume wherever I have to declare CS means code, DS means data. It is our command to the compiler. So by knowing, by typing this, our compiler will understand that, oh, whenever the CS comes, it is a code segment, and DS comes, it is a data segment. Because this data we have to use it in the particular subdivision of the memory of microprocessor 8086. Okay. For that, we have to use this first line assumption of CS is code, DS is data. So, and once data is start here, inside the data segment, all the inputs you have to use it here, you have to declare here. And one more variable I have to use it, that is sum. Sum in the sense what? Whatever the result is comes from addition of A and B, value of first and value of second addition result, that one we are going to store in the sum variable. So some variable also I have to take a data type as DW, means double word or data word. And this result we don't know. This is the fashion of question mark in the microprocessor. So for that we have to put the question mark is here because we don't know the result still in the data segment, because data segment always we have to give the values, but here no value. That's what we have to put the question mark. And this data, input data, is only we have one value, two value, and result. So that these three variables I have to declare. After that, we have to tell that this much is our data for this program. So this much is our data for this program means up to that we have to close the data segment. Close means data ends. This is our data. After that, no more data. So compiler, you have to understand that this data is ends. Okay. So I think all of you cleared these lines. Are still any doubt? Please respond me. Then only I will move to next line. All of you, are you there or not?
Yes, sir.
Yes, sir.
At least respond me, no. Okay. If you understand, then fine. So next, I will move to the second segmentation of memory, that is code segment. So this code segment is for what? We have to develop the source code of microprocessor. We have to develop our own source code of microprocessor. So here, that is that code segment we have to declare here. In the code segment, at the first beginning point, always how you are using a main function. All right, int main or void main used in your C programming. I think why I'm comparing with the C means all of you have to aware with the C programming. Okay, so here, as like in the main function in the C programming, we have to use it here start. We have to use it here start. So this is the format of using the start. That is start with the colon. Okay, start with the colon. After that, we have to use it. So you have we are explaining, right? A register, B register, C register, D register. Either AH or AL. We call it as normally if it is 16-bit AX. So for the AX means 16-bit, either AH and AL means 8-bit. So here, because of data word length, double word length, I have to use 16-bit variable. That is first 16-bit register. That first register is AX. So move AX. Okay. The first command, it means that move is a what? Mnemonic of instruction that transfer the data from source to destination. From source to destination. Here in this instruction, which is the source and which is the destination? So data is a source and AX is a destination register. What is the data? It means that whatever the data, input data are there in the data segment, those data we transferred it into a register of 16-bit. First instruction is the data, whatever data is there, that we are going to transfer it into a register. Okay. So and this a register data, where it should becomes, that should be comes for the data segment. That data is comes from data segment here. That's what in the second instruction I have to mention move ds comma x. Again, whatever the a register is getting a value, that value is stored in the 16-bit of a register. Again, that register where it is available, that is available in the data segment. That's what those registers are present in the data segment ds. That's the second line. And in the third line, so once you fix the data in the AX register, for that, where that AX register is present, somewhere in the memory location, you have to create one memory to store your result. You have to create one memory. So this is what? 4C00H. This is one of the memory address. Wherever we don't know. Computer will decide automatically. There is a one memory location address is 400H. From the 400H, that our work is starts in the memory. For that, the AX register, the starting address of that memory is register means what? It is a memory only. It is a storing element, storing device. Whatever data stored with the AX register, so that data is started with the address of 4C00 in the hexadecimal value address that is in the memory with the code segment memory. This is the meaning of third line. And in the fourth line, what we will do? We will, for doing the addition, we will do the manipulation of, again, we have to fetch the data from the data segment to code segment. How to fetch the data, how to retrieve the data. So this is the one fashion. AX is already have to created some memory. There is a one address of memory 4C00H and this AX is blank, right? So in that AX register, you have to transfer a variable value. What is a variable value? That a variable is already you are declared as 1191 hexadecimal value. Okay, so that a is nothing but what? 1191. So that 1191 you have to transfer it into the AX register. So it means that in the AX now this value is comes. Okay, same way in the second next instruction bx comma b, that bx comma b means what? Again second value whatever there in the data segment, that is transferred it into bx register. So by using these two instructions, what you understand now, the a variable value is stored in the ax, nothing but 1191, and the b variable value 2272 is stored in the bx register. So it means that ax is 1191, bx is 12272. So after that what you will do? Again there is a one instruction called as addition. For the addition purpose, yesterday only I will explain this. All the arithmetic operation ADD, ADC, SUB, SBB, MUL, IMUL, IDIV, IDIV, yes. So ADD is for addition, ADC is for addition with carry, SUB for subtraction, SUBB for subtraction with borrow, SBB subtraction with borrow, and MUL for multiplication, IMUL for silent multiplication, DIV is for division, IDIV is for silent division. Okay, yesterday only you studied. So in that, the add is used for addition of two numbers. So the AX register is with you, that is the value of 11918, and BX is with you, that is the value of 2272H. So you have to add AX and BX. It is going to be add, and the sum variable is the result. In that result, what we will get? So again, in the move sum comma AX, whatever the addition is happened, AX plus BX. After that, what the add instruction will do? The AX plus BX. After that, the result AX plus BX result is stored in the AX register. That is destination point. So this is the source. This is the destination. AX plus BX, whatever the result we are getting, that is stored in the AX register. So after that, what we will do? Whatever the value of result stored in the AX register, that AX register to we have to transfer to the sum. So sum variable already we declared here. Okay. So that in the sum we have to getting the result. That result is stored in the sum variable. So that is finished. After that, we will use the int 3. There are the interrupt 3 it is. Interrupt means what? Just if any abnormal conditions are happened during the execution of this program, that is going to be handled by this instruction. So all the interrupts we have to study in the unit number 5th of this microprocessor. Still we have to cover only 3 units. So later on you will get to know that int 3 meaning. Okay. So just you have to understand this much code, and this is for the regular flow of program execution. We have to use this in the 3. After that, our code segment is here. That code segment we have to end, means that only this is our source code. After completion of source code, we have to end the code segment. After we have to end with start. Okay. So this is the program. Still, all of you got clear this? Are you here, all of you?
Yes, sir.
Yes, sir.
So once you understood this program, now we will execute it. So I'll show the execution demo. So just all of you used the calculator. Go to base mode. In the base mode, there is a binary, octal, decimal, hexadecimal. 3 different that binary mode is there, no? So in that you have to click hexadecimal. So in the hexadecimal, you have to do the addition of these 2 numbers. How much you are getting? Addition of these 2 numbers by use the scientific calculator. Otherwise, I will show you in the Google. So in the Google also you have to get it. That is, so here you have to type hexadecimal. Hexadecimal calculator. So you will get it hexadecimal calculator here. Yes. So here you have the hexadecimal calculator. So what is our first number? Our first number is 11. Okay, I will. So here 1191H and 2272H. Okay. So that is 1191. Okay. H you don't use it, it is hexadecimal. And next number is 2272. So this is the option of addition. Here all the addition you will get it option. So just you have to click on that calculate. This is the result. So hexadecimal value of 1191 and 2272 is 3404. These 2 values are nothing but in the hexadecimal 3404. So 34 is the higher nibble and 03 is the lower nibble. Is it okay? 34 is the higher nibble, 03 is the lower nibble. So that is higher plus lower is 3403. This value we have to get it by the program. So come to this program. Just remember this. This is the value. Is our result. Otherwise, if all are use the scientific calculator. Okay. So now I'll show you the execution. Go to file. In that file, you have to save the program. Our program name is add. Add. Okay. Our program name is add. After that, you just quit this window. Again, come to the command prompt. After making exit in the file, you will come to the command prompt. In that command prompt, now you are go for second command. What is second command? Please tell me, anyone. Tell me second command.
TASM.
Yes. Yes, tell me. Another student. That is TASM.asm. Okay. So after using the second command TASM.asm, press the enter. So here you will get it 2 errors. Error messages are 2. So again, what you will do in the line number 13 and in the line number 15, you are getting 2 errors. Go to again edit command. First check it out what are the errors at the line number 13 and at the line number 15. So go to edit file. In the line number, see, it is showing the line here. Particular line you have to go. 13 line This is line number 13. And here, this is the line number 15. So for that, what you will do, 00H.
Sir, after AX it should be comma, it is dot.
After
AX, it should be comma, sir. There is dot.
okay, yes, fine. So this is the dot is there. We have to use comma because source and destination always separated by a comma, not a dot, right? Okay, fine. So this is the things. So again, save the program. Save this program. Again, exit from the window. Again, you have to use the command, that is tasm add.asm. Second command. Again, you have to check it. Enter. So now those two errors we have to remove. Okay. So once you have to getting 0 error message is 0 and warning message is 0 means none. Again, you will go for third command. What is the third command? Please tell me.
T-link add dot obj.
Okay, very good. T-link add dot obj. Okay, this is the third command. So from this command, our tasm is going to link with objective file. Our editable files are objective file. So by using this command, our tasm is going to link with objective file, means source code. So on this, you have to getting that turbo link function. It is showing which type of link we are using, and the warning no stack, that message we have to get. If the warning no stack means stack is 0, means we are in the right flow of execution of program. The meaning of no stack is we are in the right direction of execution of program. So once we got this no stack, then you will go for fourth command. What is fourth command? Tell me.
TD dot, sir, exe.
TD space file name with executable file, that is exe. So this is the fourth command. Once you click on this, means enter this command, then your output window is opening. So please all of you carefully listen, observe here. Just I have to press the enter now after the last command td add.exe. All of you observe here what it will happen. You will get the output window. So this is the output window. So on this, you have to getting the message of program has no symbol table. So because in that program we are not using any tables, that is directly addition of two numbers. So we have to click on OK. Okay. So this is the window, is output window. So in that, what you will do? In that you will go for view. In the view, so see, all of you directly don't go for run. Okay. If you go for run, automatically it is only a single step, you will get the output. So step by step, you have to understand. So go to view, click on CPU, click on CPU. The meaning is that from the CPU you are getting the data. Okay, means from the keyboard, right? So view, and after that, what you will do? Instead, don't go for run directly. All of you go for step by step execution. For the step by step execution, you have to use F7 key in the keyboard. So here I have to press F7 in the keyboard. After that, again you will go for CPU. You will get the values. Okay. So these are the values. First value is, see, this is the lower label 1191. Okay. What we are entered 1191. 11 is the lower label, 91 is the higher label. Please understand that. This is the first number. 11 is the first number of lower label, and 91 is the first number of higher label. And the second value, 22 is the first lower nibble value of second number, and 72 is the higher nibble value of second number. So how you have to read it? 1191, 2272. These two numbers we have to getting retrieved here. After that, we will go for addition, right? So here at the beginning, still we are not operated any output. So all the registers are 00, and here there is the only one AX register. That is by default the memory address is assigned by the computer. So this is the by default address of the memory from the computer. So this one we are going to change it. That is 4C00, right? So that one we have to change it here. So and remaining all BX registers, EX register, DX registers are 00, and source index, destination index, base pointer, stack pointer is also 00. So remaining IC pointer we have to use it. Okay. So in this, now you have to check it here. At this point, you have to observe if I have to press F7, what it will happen. So 4C00 it comes, right? 4C00, that is whatever we assigned in the program. AX is 4C00. From this memory address, it starts with the functioning. Okay, this is 4C00. After that, again you have to press F7. That first value you are getting here. Our first input data is 1191. That is with the AX register. You check with source code program. Okay, so that I'll show you here. Yes, and okay. Yes, fine. So here the first value is 1191 and the second value is 2272. So again I have to press the F7. We will get it. So observe that all of you. Yeah, at this position what it will happen? BX register F7. So okay. So in the BX register also we have to getting the second input 2272. 1191 2272. So these one again where these after the addition. So next we will go for addition of AX plus BX. This register addition of AX plus BX. What is AX? AX is 1191. BX is 2272. So add these two numbers, and after adding these two numbers, the result is stored in where? That result is stored in again AX register, because destination plus source, and the result is stored in the destination register. So the destination register is here AX. So after I'm clicking the press F7, you have to check that AX register is changing or not. So how much we are getting? The output in the Google, you have to check it. Something we are getting no in the calculator. So AX again I have to press the F7. What is that? 3404. Addition of AX plus BX is 3404, and that addition value result is stored in the AX, isn't it? The result is stored in the AX, yes or no? So that is 3403. You have to check it. Is it the same value or not? Hexadecimal. See, 3404, right? It means that we are right. 3403. So our result is also 3403. This is the addition of two numbers. All of you got it?
Yes, sir.
Yes, remaining student, only one of students are responding always. What about remaining student? So if you are clear, what you will do? You have to execute this program and send me your output screen to my personal WhatsApp number. Then only I understand that you are understood everything about this program. So otherwise, if you are not understood anywhere, please ask me where you are not understood. One more time, I will explain you that concept. If you understood, you send me output screen to me. So if questions, please. Okay, if no question means take your own time. This is the first lab session, practicing the lab session. Take your own time, execute this program and send me output screen to me. I will give you 30-minute time for this. Okay, now it is 120, near about 120. You have to send me within 150 of your output screen. I am waiting your answer, your output. Is it okay? Okay, fine. You will carry this task. Uh, Once you got the output, next you will go for subtraction. Same thing. In the subtraction, what you will do? Just you use instead of add in the program. So that is in the program add. So this one you use it for sub subtraction, and this sum you use it for differentiate. So DIFF you have to use it here. Okay, in the DIFF you use it, and this add you have to use it sub. You will get it subtraction of this program. So first half an hour, all of you execute this program. After executing this program, go for subtraction. Only in this line you have to change, instead of some other variable you take for differentiate DIFF, and here instead of addition you have to take for subtraction sub. Remaining everything is same, you will get the answer. And here your needful value you have to change it. So first 30 minutes, all of you execute this program and send me the output screen. Once you execute it, within 5 minutes, you change these two code and send me that one also. I'm waiting up to 2 o'clock. You have to done this task. Otherwise, if any questions, you have to ask. Yes, sir.
Excuse me, sir.